Now see next question from exercise 5.5, question 4, sub question 1. Box product of A bar, vector B bar plus C bar, vector A plus vector B plus vector C is equals to 0. And second, so first we solve first sub question. So write in solution A bar, B bar plus C bar, A bar plus B bar plus C bar is equals to. Now for solving this problem, we have to apply the properties. First property is A bar cross A bar is equals to 0 vector. So similarly for vector B, similarly for vector C, that is B bar cross B bar equals to 0 vector, C bar cross C bar is equals to 0 vector. And this box product we have to reduce into scalar form, that is as the form A bar dot B bar cross C bar. So for calculation we reduce this box form into scalar and cross product form. So we write this as A bar dot in bracket B bar plus C bar cross A bar plus B bar plus C bar. So first we solve this bracket, that is cross product. So write A bar dot in bracket. So multiply by vector B. So we write B bar cross A bar plus B bar cross B bar plus B bar cross C bar. Now then multiply by vector C. So I write that in lower side to it. So C bar cross A bar, C bar cross A bar plus C bar cross B bar plus C bar cross C bar. Now by this property, this A bar cross A bar is 0 vector, B bar cross B bar is 0 vector. So this vector is 0. This vector is 0 vector. So we write the remaining terms. So write as A bar dot B bar cross A bar, then this plus B bar cross C bar, then C bar cross A bar plus C bar cross B bar. Now multiply by this vector A. So we have to take scalar multiplication. So write here A bar dot B bar cross A bar plus A bar dot B bar cross C bar plus A bar dot C bar cross A bar plus, and this last as A bar dot C bar cross B bar. Now we know that when one vector is repeated, then their scalar triple product is 0. That means A bar dot B bar cross A bar. Here vector A is repeated, then its scalar product is 0. So this first term vector A is repeated, so its value is 0. In third term also vector A is repeated, so its value is 0. So we write the remaining terms here A bar dot B bar cross C bar, then this plus A bar dot C bar cross B bar. Now in scalar triple product, when we interchange any two vectors, suppose vector A B C, or we write A bar dot B bar cross C bar. If we interchange these two vectors, then its value changes by sign. So we write here A bar dot C bar cross B bar. So similarly, if we interchange this B with C, we write this as A bar dot B bar cross C bar minus A bar dot B bar cross C bar. So these are the like vectors, that means their difference is 0. So in this way we get this box product equals to 0. Okay, second sub question. So first we solve this bracket. We consider here LHS. LHS is equals to A bar plus 2B bar minus C bar dot A bar minus B bar cross A bar minus B bar minus C bar. So first we cross multiply these two vectors in bracket. So A bar plus 2B bar minus C bar dot. So multiply by this vector A. So we get A bar cross A bar minus A bar cross B bar minus A bar cross C bar. First we multiply by A with this vector A, then with this vector B, then with vector C. So we get A bar cross A bar cross B bar, A bar cross C bar. Now multiply by this vector B. So we write here plus minus minus. So I write here B bar cross A bar minus minus plus B bar cross B bar minus minus plus B bar cross C bar. So we multiply A with A, this B with B, B with B, B with C. So in this way we get the value. Now apply the same rule that we used in previous sub question 1. So A bar cross A bar equal to 0, B bar cross B bar equal to 0, C bar cross C bar is 0 vector. So we write here A bar plus 2B bar minus C bar dot. This A bar cross A bar is 0 vector. This B bar cross B bar is 0 vector. So we write the remaining terms. So here minus A bar cross B bar minus A bar cross C bar minus B bar cross A bar. So this minus B bar cross A bar, if we interchange, we write this as plus A bar cross B bar. Then this B bar cross B bar is 0 plus this B bar cross C bar. Now this minus A bar cross B bar and plus A bar cross B bar get cancelled. So we write here A bar plus 2B bar minus C bar dot. So we directly write only minus A bar cross C bar and B bar cross C bar. So first we write the plus term B bar cross C bar minus A bar cross C bar. Because we cancel these two terms, this minus A bar cross B bar cancel with this plus A bar cross B bar. Now multiply by A to each term of this second bracket. So we write here A bar dot B bar cross C bar minus A bar dot A bar cross C bar. We multiply by vector A, then multiply by vector 2B. So we write here plus 2B bar dot B bar cross C bar minus 2B bar dot A bar cross C bar. Then multiply by this vector C. So write here minus C bar dot B bar cross C bar minus. So minus minus get plus here plus C bar dot A bar cross C bar. Now when vector is repeated in scalar triple product, their scalar triple product is 0. So write this first A bar dot B bar cross C bar as it is. So we write here A bar dot B bar cross C bar. Now here vector A is repeated, that means its value is 0. Here vector B is repeated, so its value is also 0. Here minus 2B bar A bar cross C bar, so keep as it is. So right here minus 2B bar A bar cross C bar. Then vector C is repeated, so its scalar triple product is 0. Here is also vector C is repeated, its scalar triple product is 0. So the remaining terms are these two only. So write first term as it is A bar dot B bar cross C bar. Now this A bar cross B bar, if we interchange, so this can be written as plus 2B bar dot C bar cross A bar. Now this is in cyclic order, we know that. vector ABC is equivalent with vector BCA. Vector BCA is equivalent with vector CAB. So this BCA, this vector BCA can be written as vector ABC. So we write this as A bar dot B bar cross C bar plus 2 times A bar dot B bar cross C bar. So this is A bar B bar C bar plus 2 times A bar B bar C bar, which is equal to 3 times vector A B C, box product of vector A B C. So in this way we can show LHS is equal to RHS, which is equal to RHS, hence proved. Now see next question, question number 5. Vector C equals to 3A bar minus 2B bar. Then prove that vector ABC equals to 0. Box product vector ABC equals to 0. So we consider here LHS. LHS is equals to box product of vector ABC. So we write this as A bar dot B bar cross C bar. Now replace this vector C bar as 3A bar minus 2B bar. So we replace this C bar as 3A bar minus 2B bar. Now multiply by vector B. Here multiplication is cross multiplication. So we write here 3B bar cross A bar minus. So here minus sign we write at first position, minus 2 into B bar cross B bar, which is equal to. Now this vector B bar cross B bar, we know that cross product of like vector is 0. So this value B bar cross B bar we write as 0 vector. So this value is 0. Now write the remaining terms. A bar dot 3 B bar cross A bar. So write this 3 A bar dot B bar cross A bar. Here in scalar triple product vector A is repeated. So when vector is repeated its value is 0. So we write here 3 into 0. We get 0, which is equal to RHS. So when vector C equals to 3A bar minus 2B bar, then this box product of vector ABC equals to 0. Now see question number 6. If vector U equals to I minus 2j plus k, vector R equals to 3i plus k, and vector W equals to j minus k are given vectors, then find U bar plus W bar dot U bar cross R bar cross W bar. That means we have to find the scalar triple product. For that we find this vector U bar plus W bar, then this cross product of vector U bar cross R bar, and then R bar cross W bar. Then we have to find this scalar triple product. So first we find U bar plus W bar. So in solution, first we calculate each bracket value. So U bar plus W bar is equal to. Now add the vectors. Now write the vector U as I minus 2j plus k plus vector W as here vector I is absent, so we write 0i plus 1j minus 1k. So addition of this vector is here we write 1i, here we write 1k. So 1 plus 0 we get 1, so we write 1i minus 2j plus 1j, so we write here minus 1j. Then 1k plus minus get cancelled, we write here 0k. Now this is the value of U bar plus W bar. Now we have to find the value of U bar cross R bar. Therefore U bar cross R bar is equal to, so we have to use the determinant. In first row we write ijk, In second row, we write the coefficient of ijk of vector u. So vector u is I minus 2j plus k. So we write here 1 minus 2 1, 1 minus 2 1. Then r bar is 3i plus. So this also written as 3i plus 0j plus 1k. So we write here 3 0 1 plus minus plus. So calculate this cross product first. That means solve this determinant. So we get I cap minus 2 into 1 is minus 2 minus 0 minus j. 1 into 1 is 1 minus 1 into 3 is 3 plus k. 1 into 0 is 0 minus minus get plus 2 into 3 6. So we get here minus 2 minus 0, that is minus 2i. Then 1 minus 3 minus 2 minus plus. So we get here plus 2j plus 6k. Now then we have to find the value of r bar cross w bar. So write r bar cross w bar. So in first row we write ijk. In second row, coefficients of ijk of vector r, that is 3 0 1, 3 0 1. Then coefficient of ijk of vector w. So here vector I is absent, so the coefficient of I is 0. Then coefficient of j is 1, coefficient of k is minus 1, which we already write here. This vector w bar as 0i plus 1j minus 1k. So find the determinant value. So here I cap 0 into minus 1 is 0 minus 1. Then minus j in bracket 3 into minus 1 is minus 3 minus 0. Then plus k in bracket 3 into 1 is 3 minus 0 into 0 is 0. So we get here 0 minus 1 minus 1, that is minus I. Then minus 3 minus 0 minus 3 minus plus 3j. 3 minus 0 is 3, that is plus 3k, or you can write this as minus 1 into I. Now we calculate the value of u bar plus w bar. U bar cross r bar cross w bar. Now substitute this value. So we get here, we have to find here u bar plus w bar dot u bar cross r bar cross w bar. That means we have to find scalar triple product. That means we have to calculate the determinant here. So u bar cross w bar is 1i minus 1j plus 0k. So the right coefficient of ijk 1 minus 1 0. Then u bar cross r bar is minus 2i plus 2j plus 6. So write here minus 2 plus 2 6. Then r bar cross w bar is minus 1, then 3, then 3. So we have to calculate this. So write plus minus plus. So we get here plus 1 in bracket 2 into 3 6 minus 6 into 3 18 minus. So this minus get plus. So plus 1 into minus 2 into 3 minus 6 minus. So minus get plus 1 into 6 6. Then plus 0 into minus 2 into 3 minus 6 minus plus 2. So we get here 6 minus 18, that is equals to minus 12. Minus 6 plus 6 get cancelled. So we get 0 plus 0, which is equals to minus 12. Now see last question of this exercise. Find the volume of tetrahedron whose vertices are a of minus 1 2 3, b of 3 minus 2 1, c of 2 1 3, and d of minus 1 minus 2 4. Now we have to find here volume of tetrahedron. We know the formula for volume of tetrahedron. If its coterminous edges are given. Now see here, if P bar, Q bar, R bar are the coterminous edges of the tetrahedron, then volume of tetrahedron is equal to 1 by 6 times box product of vector P bar, Q bar, R bar. That is scalar triple product of the vector P, Q, R. So first we write here position vector of each point. Then from this point we write coterminous edges. So we write here position vector of each point. So write in solution, let A bar, B bar, C bar, D bar be the position vector of points A, B, C, D respectively with respect to origin. Therefore, A bar equals to, now write the value of vector A from this point A, which is minus I plus 2j plus 3k. Then value of vector B is equals to, from point B, so we write here 3I minus 2j plus 1k. Then position vector of point C, which is C bar, so write the value of C bar as 2I plus 1j or only j plus 3k, and value of point D with position vector D bar, so D bar equals to minus I minus 2j plus 4k. Now we have to find the coterminous edges. So there must be one point common. So we write here vector AB, vector AC, vector AD. So these will be the coterminous edges of that tetrahedron. So we find vector AB as position vector of B minus position vector of A, that is B bar minus A bar. Here AC bar, vector AC bar means C bar minus A bar, and here vector AD means D bar minus A bar. So write here B bar minus A bar as 3 minus 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 plus, so we get here 4I minus 2 minus 2, so we get here minus 4j. Then 1 minus 3, so we get here minus 2k, or you can write here sign as here after changing plus, here minus. So you can use this sign for calculating directly. That means 3 plus 1, so we write here 4I. Then minus 2, so we get minus 4j. 1 minus 3, so we get minus 2k. Similarly for vector AC, so here 2 plus 1, so we get here 3I. Then 1 minus 2, so we get here minus 1j, that is minus j. Then we get here plus 3 minus 3, which is 0k. Then D bar minus A bar, minus 1 plus 1, so we get 0I. Then minus 2, so we get here minus 4j. Then 4 minus 3, we get 1k. Or you can write one more step. You write the value of vector B, then vector A, then subtract. If you get the value directly, you can write directly that values. Now we have to use the formula for volume of tetrahedron. So write the volume of tetrahedron equals to, therefore volume of tetrahedron is equal to 1 by 6 times box product of vector ABC. So in place of vector ABC, we have to write vector AB, vector AC, vector AD, vector AB, vector AC, vector AD. That means we have to find this box product. That means we have to calculate the determinant. So write that value in determinant form. So write the coefficient of ijk, 4 minus 2, 4 minus 4 minus 2, then 3 minus 1 0, 3 minus 1 0, then 0 minus 4 and 1. So write plus minus plus. So we get 1 by 6 in bracket. So 4 into we get minus 1 into 1 is minus 1, minus 0, then minus minus plus 4 into 3 into 1 is 3 minus 0, then plus minus minus 2, 3 into minus 4 that is minus 12, minus 0. So 1 by 6 in bracket. Minus 1 minus 0 is minus 1 into 4 which is minus 4. 3 minus 0 is 3. 4 into 3 12. So we get plus 12. Then minus 12 plus 0 is minus 12. Minus minus plus. So 12 into 2 we get 24. 1 by 6 in bracket. So add these two. 24 minus 4 we get 20. 20 plus 12 we get 32. So here we get value 32. That is equal to 32 by 6. Or you can write, if we divide by 2 we get 16 by 3 cubic unit as the volume of tetrahedron. So in this way we can calculate volume of tetrahedron.